Last 5 chapters and this playlist has already covered the fundamental of JSON data files and why data engineers should know about it. Basic JSON processing using colon, bracket and dot notations. JSON data file loading using S3 bucket and via SNOSQL to internal stages. JSON data file as external table, different JSON file structures and working with complex and dynamic JSON dataset and how to use SQL functions to process JSON data files. This chapter, chapter 6, is one of the important chapter that can help you to simplify your JSON processing and will bring a lot of muscle power to your JSON Snowflake knowledge. We are going to decode how to use flatten table function to process complex as well as nested or a deep nested JSON data file and try to solve a couple of real life example using this table function. This chapter will cover following topic in the context of flatten function. What is flatten function or flatten table function? How to use it for different data types, be it JSON or array or object data types. Will the JSON structure be the most suitable to use flatten function? Flatten function outputs, flatten function input parameters and their default values. Is there any limitation with the flatten function? And the performance of flatten function. If you are familiar with the different kind of joins in SQL, you may find my explanation relatively simple. And if you feel bit harder to grasp it at first time, I would request you to watch this video one more time and also try to run those queries in your free trial edition. During my hands-on exercise, I will make mistake intentionally with my SQL statement to demonstrate the behavior and the error which are thrown by Snowflake and sometimes how hard it is to debug those flatten table function mistakes. We will also go and discuss the query profile screen and understand the associate steps. This chapter is completely hands-on chapter. You would come to know a lot of interesting thing about flatten table function. Welcome back to my channel Data Engineering Simplified and to this Handling JSON Data in a Snowflake playlist for true data professionals like you. This is a complete playlist to cover JSON handling in Snowflake. Link for all the chapters can be found in the description section below or click above in the information icon. So let's start with chapter 6, JSON data and flatten function. So let's start with basics. There are more than 500 built-in functions in Snowflake and they are classified under different categories. For example, scalar functions like date and time, aggregated functions like min or max, window functions like lead and lag, table functions like generator, and system function like cancel query, etc. We have already covered custom and built-in function in detail in our Snowflake playlist video. You can refer the link in the information icon to watch if you want to go much deeper on custom and inbuilt functions. So let's narrow down to flatten table function. Since flatten is a table function for any given input or inputs, the function returns a table and table will have data in form of rows and columns. Flatten is a very common table function. It is not necessary that it has to be used only with a JSON or a variant data type, but it can also be applied to other complex data types like array or an object. In the Snowflake documentation, the term flatten is also referred as explode, and we will quickly see what this flatten does with array and object. So it will be more clearer to you how it has to be used with JSON data file, as JSON data file is nothing but a key value pair and it can also encapsulate array and object, and that's what this flatten function will deal most of the time. So let's jump to our Snow site and start understanding this flatten table function. So I am in my Snow site web UI. This is my first worksheet. Let's quickly change the context. Let's say I have a table called employee and it has an array field that stores employee's technical certification information. So this is how my table looks like. It is called EMP01. It has ID, first name, last name, and designation of an employee. Then it has certification detail. So the data type for certification column is array. This is my first record where the employee 1 has only one certification. So I'm constructing an array through this array construct. Let me run this for you and show you how does it work. So you can just put the select followed by the function name and followed by this one input. This is how it looks like. And if I hover on this particular part of the result, it says it is an array. So let me create this table and then let me insert the first record. So my table emp01 successfully created. I'm going to insert this first record. The second employee is senior Snowflake developer, and this person has two certification. That's why this array construct is taking two different values. So let's execute this. The third employee is Snowflake architect, and this person has three different certification, and that's why array construct is taking three different input values. Let's run this insert statement. Now let's check the data and validate how does it look like. So if you see the result, first employee is a Snowflake developer and has one certification. Second employee is a senior software developer, has two certification, and third employee is a Snowflake architect and having three different certification, right? So if you understand the table relationship, if I have to store this certification in a separate table, it would be one-to-many relationship. Each employee may have zero or more certification available, right? Now, what if I have to generate an output like this, where my employee, for example, Alexander, is having a certification Snow Pro Core, Pierre is having two certification, Snow Pro Core and Snow Pro Advanced, and Isabel having three certification, Snow Pro Core, Advanced DE and Architect, right? So if I run this particular select statement, I am getting only 3 rows. However, I am expected to get total 6 rows because total number of certifications are 6. Now let me run this select array construct for you once again. This is bringing just one result. However, my expectation is to explode this result into a individual rows and should get 3 rows. Now let me show you how can I write the flatten function, and then I would go and explain. Since flatten function is a table function, it has to be used with the keyword table. Okay, then I'm going to use a word flatten, and then it takes certain input, and this is the operator I have to use to pass the input, and then I can copy this input because this is my array object. Okay, and that's it. And let's run this statement and see the result. Now I can see the entire array list is converted into a table format, and this value is nothing but those individual element which is there in my index 0, index 1 and index 2. So right now don't focus on sequence, key, path and this. By using this flatten function, I managed to explode or flatten this list value into a row value. Here I have used a static list. Now if I have to apply the same flatten function into my emp01 table, how can I do that? Okay. So when you have to pass the input value from a table, the structure of this entire SQL looks slightly different. Now let me write the SQL for you. So the name of my table is emp01, which I am giving an alias called emp employee, and then I am using lateral keyword followed by flatten, and then I am giving this input employee followed by I am using this certification because this employee dot certification is nothing but this array construct in our case, right? Okay, and I am giving name called certification, and that's it. So when I run this, I am going to get total 6 values. So let's run this statement and see what result does it bring. So if you look into the result, it has brought ID, first name, last name, designation and certification as the result from the EMP table, and followed by it also has sequence, key, path, index and value, what we have seen as a result of this line number 43, and the total number of result is 6. If you see the total number of rows, I got it 6. Now let me modify this query for you. Now if you pay attention, This flatten function return a tabular result, and from that what we are looking for, we are looking for a column called value, and this value is having the certification detail. So I have to print this value using this alias name. So I am taking this alias and I am saying value, and I am typecasting is to varchar, okay, and giving a name as certification. Now let me run this query for you. So now I can see Alexander has certification Snow Pro Core, Pierre has Snow Pro Core and Advanced DE, and Isabel is having 3 certification: Snow Pro Core, Snow Pro Advanced, and Snow Pro Architect. So this is how I have used the flatten function, and in the flatten function I am passing the input as the array, which is this particular array, and flattening it and generating multiple rows out of that list. This is one way I can use the flatten function and explode or convert my list into row. So flatten function take another input called mode, and let me put that here mode, and this mode could be JSON or array or object. So right now this particular input is an array. So if I put array in all lowercase, let's see whether it brings the same result or not. Yes, it got the same result. But if I change from array to JSON, let's see what happens. It says bad flattening mode JSON, not both array or object. Little hard to understand, honestly speaking. But if I just change it from JSON to object, and if I run this, it says bad flattening mode object for array input type at position 1. The error code is 100170. Okay, so by looking at these errors, it is hard for you to understand what's going wrong. If I remove this comma and try to run this again, it will be hard for you to debug. Let me run this, and it says unexpected mode. Okay, and by looking at the syntax error line number 5 at position 55, why this particular statement is not working. If I give it simple JSON, okay, this will also throw a little cryptic. So invalid identifier JSON, because it is not able to identify that input value. So make sure that when you are using the flatten function, you have to understand how you have to pass the different input, what is the default value, whether it has to be enclosed with a single quote, double quote, or you don't have to enclose at all. So this is a very simple flatten statement which we have used to explode our array list into a multiple rows. So what we have seen, we have flattened an array data type using the flatten function. So we have 3 elements in our array, and this is coming in a single row. And when we have applied the flatten table function, this 3 element which is there in a single row is converted into 3 different rows. And that's why it is also called as a exploding this particular list into multiple rows. This table function also generate other columns like sequence, key, and path. And for the array data type, they are not very meaningful. And we will see when we are going to use either object or a JSON data type. At the same time, the column this actually gives you where this particular value is extracted from, so that entire list is available as this object. So for example, if you want to apply a filter clause where you want to only see all those employees who are Snow Pro Architect certified or Snow Pro Core certified. So once you apply a filter criteria on the value column, you would get the filtered result as a part of your query. So now we are going to jump and explore how the object data type works and how it is different from array. So this is my another worksheet. Let's quickly change my context before we run the queries. This is my employee 02 table, and the only difference you would see here, I have a certification object instead of certification field as an array. So let's create this table emp02. When I'm inserting the record, the first 4 column looks exactly same. Instead of using array construct, I am using object construct, and here I am passing 2 parameters, and we'll see how this works little differently from our array construct. The first is a name of the certification and second is the score. So let me run this insert statement. The employee Alexander got inserted. My second employee has two certification, Snow Pro Core and Snow Pro Advance. Now my third employee Isabel has three certification. So I have total six inputs given into this object construct where it start with the name of the certification followed by the score. So let's insert this record. Now let me run this statement for you. And let's see how this object construct generates an output. So if you look into the result, it has automatically converted this object into a JSON format. And when I click on this result, here it is not saying it is a variant data type, but it is saying it is an object data type. And if you look into the result, it is considering the first input as a key, second input as a value, third input as a key, fourth input as a value, and fifth input as a key, and sixth input as a value for this. Let me run the select statement from emp02 table. And I can see I have a total 3 employee and each employee has a certification detail along with the passing mark in the certification. Looks good. Now, how can I use the flatten function? Let's say I want all the certification to appear as a result along with a score, and who has achieved that certification, their name should also come. So if this is my output, how can I achieve this output? Again, a flatten function can help me. And before I write a flatten function directly on the table, let's write a flatten function on this static value. So for that, select star from table, and here I am going to write flatten. Then I will simply copy paste my object construct and let's see what value does it give. Sorry, I made a mistake. So the Snowsite web UI automatically understand the open bracket and closing brackets. So it helps you to become more productive. So let me run this query once again. Now I can see I have got 3 rows because it was coming as a single row. Now using the flatten function, I managed to get 3 different rows. So now if you look in the previous flatten function, when we have given array as an input, the path was coming more like an index. Here I do not have an index. I primarily have a path which is nothing but a key, and this is the value, right? Now let me modify the query a little bit and show you how can I use either key or a path or a value. So I can say path key value, and let's run this because this is associated with this table. So I got the key and I got the value. The value is again a variant data type. So I have to convert it into a number or a varchar according to the right data type for the value. So I can say number and run it. So now I got the certification as well as the value. Okay. Now let's say that I am going to add another value called only key but no value. So what happens? Let's see. So it says that the invalid number of argument for the object. So when I was using array construct, I can simply give this array construct here and run this SQL statement. It will generate total 4 values. It does not complain. So there is no key value based approach. However, when you are using object, you need to have a key value. Otherwise, your SQL statement will not work. Okay. So let me run once again. Now I can see my key and value. Now you see sequence is 1 because it is just one record, and the keys are nothing but which is representing the key in the object, and the path, it is actually taking this path, and then it is giving a value. Now let's give other input like a mode or a path, and let's see what result does it bring. So I have to give a comma and then I will say mode. Snowflake automatically understand what is the object type, but I can also specifically mention that. So let's mention it object and let's run that. So I am using a mixed case here, and let's see whether it brings the right result or not. Good, I got the result. Instead of object, if I give an array, let's say what happens. It says that bat flattening mode array for object. So it clearly says that this is an object data type and you are passing an array as a mode. If I say JSON, it should also say that bat flattening type JSON. Okay, this is also a JSON, honestly speaking. So I can use parse JSON, and in that case it should work. Let me try that. This is also not working because this is not a true JSON. So we have seen how to use the flatten function using this static object construct. Now let's try to use it with a table which has object as a data type. So let's quickly write our SQL statement. Let's see how the data looks like here. So I have total 3 employees, and each employee has a certification, and the certification column is an object column. Let's verify that. So if you hover on this part of the result, it says it is an object. I am having total 1, 2, 3, 4, 5, 6, total 6 certification. And I want the result should appear like this, where my certification column gives me the name of the certification and the score column gives me the score for that certification by the particular employee, and the employee name should come as a first. Good. So here I can say employee dot star. Okay, and this will give me all. Now I am going to use the lateral function, lateral, and then I say flatten, and in the flatten needs an input, and input will be this employee tables certification column. Okay, and I can here say cert dot star. Okay, now let's run this statement. So what happens? This flatten function, the way we have used here, generates a temporary table, and that table is joined with all the element available in this particular employee table. So in one way, it is nothing but a join condition where the result from the certification is flattened or exploded and combined with the result of employee data, wherever the employee ID matching with the employee ID from this explosion. So let me run this statement for you. So I can see I have employee ID to designation, and this certification is coming as an object, and then I have sequence onwards until this is result coming from the flatten function. Okay, and if I have to really get the result the way I expect it, I have to use cert.key and cert.value. Let me modify the query. Since it is a variant data type, I have to convert it into number. I can simply use this. I can go here and I can say format my query. It has formatted my query, and now let me run this query. Now I can see I have a first name, last name, Snowpro core certification, and a score. Okay, perfectly fine. And if I try to see the query profile, let's see how does it look like. So it has scanned the table as usual. Then there is a flatten function. If you click on the flatten function, it indicates that what is the input considered for this flatten function, and finally it displays the result. And this is how I can look into SQL text, and if I want, I can also export the result from here any point of time if I have the appropriate role to download and export the result. Now again, we can use the mode here. We can also use path equals to, we can give empty for now, and let's see what happens if I run this statement. It is bringing the same result. Let me see the query profile. If I click on that, you can see it has taken 3 different input: the column input, the mode input, and the path input. There is one more input which is called recursive, and let's try that. By default it is false, but I can make it true. Okay, and let's run this statement once again. Since there is no recursive object inside the object, the result has not changed. It has brought exactly the same result. but I can go to the query profile and check. So when I click on the flatten function, I can see it has taken recursive as an input. So we have seen how array data type works with flatten. Now we have seen how the object data type works with the flatten. And stay with me, we are going to see the most exciting part of this video is how to use JSON data with flatten function. We have seen how the object data type can be used within flatten function, and it can be flattened or exploded to multiple rows. So in this example, we had total 6 element, which is nothing but a key value pair, and this key value pair appearing as a single row. And when we use this flatten function, we managed to explode that single row into 3 different rows, and we extracted key inside the key column and value inside the value column. So why we are trying to understand array and object? Because your JSON data file may have an array or object inside array or array inside object. And once you know how to flatten your array object as well as JSON object, and once you know how to explode or use the flatten function with array data type or an object data type, it would be much more easier for you to write appropriate SQL statement to explode the array or object which is part of your overall JSON document or JSON data file. So let's use another example to understand our flatten function. And in this example, I am going to use 2 different columns. One column is an object data type, another column is array data type. So I am creating a table, a mobile table, which is having a multiple camera, and this table is recording the name of the mobile, the brand of the mobile, what is the pixel size for the front camera, what is the pixel size for the rear camera. However, there are multiple rear cameras, so this will have multiple element, and I am also capturing the length, width and height of the mobile. So this is an array object. So let me create this table. My mobile table is created successfully. So let me insert my first record. So this is my first record where it is iPhone 12 having the front camera as a 12 megapixel, and I am constructing an object where the iPhone 12 has 2 rear camera, which is a primary or standard camera of 14 megapixel, and wide angle camera is 16 megapixel. These are just demo values, and I am constructing an array where length, width and height is representing in 3 different elements in this array. Let's insert this data. Let's see how the data looks like. So if I click on the rear camera, it is representing as an object. And if I click on this dimension, length, width and height, it is represented as an array. And I can see there are total 3 elements. Looks good. Now I want to explode this 2 values, and for that I would like to use a flatten function. Let me write the SQL for you quickly. Select star from mobile, and then I have to use lateral function, lateral followed by flatten, and it will take an input, and in this input I am using this object construct. So I will say mobile dot object mobile dot rear camera, okay, and I will say rear, okay, and here I will say mobile dot name, rear dot key. Let me rerun. So I can see iPhone 12 primary or standard camera 14 pixel, wide angle is 16 megapixel. Good. Let's quickly see the query profile. Pretty standard. I have this input mobile rear camera, looks good. If I have to explode the second one, how can I do that? In that case, you have to again use another flatten function along with this first flatten function. So I am using comma here, and then I am using lateral flatten, and I am using input this, and now mobile, and I'm giving this dimension, okay, and I will say dim. So line number 24 generates a temporary table, and that temporary tables is joined with this result. Now it is going to generate another table which is called dim temporary table, and this dim temporary table will join in the combination of this record and all the rows from the rear. It means if I have 2 record from here and 3 record from here and 1 record from here, it will be totally 2 multiplied by 3 equals to 6 record. And let's see how does it come. So here I am giving dim. Since it is just a value, I can say dim dot value because I don't have to use a key here. And let's see how the result appear. So I can see the iPhone 12 is coming total 6 times. Primary camera is coming 3 times because I have a 3 different dimension, and wide angle is coming 3 times because again it is a 3 different dimensions. Like, though this is not a very meaningful result, I want this length, width and height should come as a column, not as a row. However, you will get a JSON where you will have a multiple objects inside object, and you have to use multiple flatten function to explode your data, and the number of rows is a product of each of those lateral function multiplied by the number of rows in your main table. Okay, now let's go and check the query profile. So what you see here, the first table is scanned and table got only one record. Then it used the first flatten function, which is using the rear camera, and this rear camera was nothing but an object construct. It means it has a key value. So if you have n number of key, you will get 1 multiplied by n, and then you actually used another flatten function which is nothing but an array. So the number of element is here 3, which I can say m. So it will be 1 multiplied by n multiplied by m. That many records will appear on your screen, right? So let's say that instead of extracting all the dimension values, I am only interested in a length. So how can I write a where clause? So I can say where, I will say dim dot, if I go to the result here, this is my 0th index, this is my first index, and this is my second index, and index, okay, and index is 0. If I say index is 0, it means only fetch the value which is index is 0, and I can put dimension instead of dimension value. I can say dimension dot index, and let's see what value does it bring. I can see 0th index and the pixel is only 1. So it is giving 14 megapixel, 16 megapixel, and the length is 16.49 centimeter, right? So this is how I can use the flatten function for a different data type and apply the where clause, or apply the where clause and extract the necessary information from the flatten function and narrow down my result as expected by business or my use case. Now finally, I am going to process the JSON files, and this is my new worksheet. Let's change my context. I am going to create another table called EMP04, and which has only one column, which is called JSON data of data type variant. This JSON data is storing the employee information, what we have seen earlier, the name of the employee, the designation of the employee, and the certification the employee has taken, and the score the employee has achieved for each of the certification. So this is what my expected result from this variant data type. And let's insert the 3 records before we start querying the JSON file using the flatten function. So this is my first employee, and this is a complete valid JSON record. And let me go back to our JSON editor and see them. So this is a valid JSON, and employee ID is 1, name Alexander, designation is Snowflake developer, and certification is Snowpro Core marked 790. These are the elements in the root level, followed by the certification which has only one element in the array, and this is how it looks like. So let's insert this record, and here I am using a parse JSON function to parse the JSON before it is inserted for the variant data type. And if you have not seen my first 4 and 5 videos, I would request you to go and watch those videos. A lot of concept about JSON is covered on those videos. So let me insert this. Now this is my second record. Let's quickly validate that. Also valid JSON, employee 2, 2 different certification. Now going for third employee, which has 3 certification. Let's quickly validate this also. So I can see total 3 certifications. So I can see total 3 results populated, and let's click any one of them. So I can see total Three certifications with employee 3. Looks good to me. Now I am going to use the flatten function and it will work exactly the way it has worked for array and object. So before I use the flatten function, let's try to use the standard colon and dot notation to extract the JSON element. Okay, let me run this query. So I can see the name, designation and certification, which matches my name, designation and certification. Looks good. Now I want to make sure that we have total 6 certification. So I should get total 6 rows. And for that, I would like to use the flatten function. So since this is an array, we have seen how to use the array to flatten it. So I'm going to use the comma and then use the keyword lateral and then flatten. And once I have a flatten, I will use the input keyword and I would say I will take this entire content and put it over here. That's it. And I will give cert. Okay. Now here first let's do cert dot star. I'm going to print all the columns given by this lateral table function. Okay. And that's what I'm going to do that. So the first 4 column is representing the first 4 field in this select statement. The moment I move it, it gives me sequence, key, path, index, and value. Now, if you look into the path, it is slightly different here, 0, 0, 1, 0, and 1, 2, right? And index is always like 0, 0, 1, 0, 1, 2. We'll go little deeper into this. And if you see, my sequence is also changing here because now I have total 3 records. So sequence 1 represent the first row, sequence 2 represent the second row, sequence 3 represent the third row. When we exploded the third employee, it actually converted into 3 rows. Index for those array element is 0, 1, 2, right? Here we are not using any key. So your JSON flatten function is not very different from your array data type and object data type. If I don't like to use the flatten function, then I have to use the index notation to extract all the certification. And for that, I have to say 0th element as a certification name. And then I have to use first element as a certification score. If I just remove this part and let's see how does it work. Now, this is my certification name and certification score. So I have to fix it. So now I see only 3 result. It has not given me all the 6 result which I'm expecting. So when you have a dynamic values and you do not know how many elements you will have inside your object or an array which is part of your JSON data, your index based extraction doesn't work. And that's why you have to rely on the flatten function, because flatten function will create the table from this input values and then it explode it, and finally it joins your exploded data with your main data set and provide that one-to-many relationship. Now let's take another JSON example. And here we are trying to explore other parameter for our flatten table function. So this is my new worksheet. Let me quickly change my context. I am going to create a table called employee JSON, which has a variant data type called emp underscore JSON underscore data, and it has a stage file format associated with it. We have already seen how to use stage file format in our previous chapter. So let me create this table. We will load sample employee JSON data and we'll run a copy command to load the data, and then we'll use a flatten function. Before running the copy command, I need to make sure that I have the data file available in my stage location. I do not have any data file available in my table stage location. Let's go and put some data in this stage location. So this is my put command where I am placing a employee1.json file into the table location, and auto compress equals to false. So one data set is loaded successfully. Now let me run this list command once again. I have one employee data, and let's see how this employee data looks like through our JSON visualizer. So this is an employee data, and this is how the JSON structure looks like. If you look into this visual diagram, it has ID, full name, designation, department, salary, and so on. And the employee has multiple programming skills. So this particular element is encapsulating an array. So the the employee knows multiple programming language, in this example JavaScript, C++, and Python. And then the employee has a different proficiency level, for example beginner, intermediate, or expert. And the overall experience having this programming language is also encapsulated as an object. This entire programming skill is an array, and this array has another object, and this object has another object. So there is a nested element within the element. On the line number 37, the employee has database proficiencies, and here SQL Server, MySQL, and again here also the year of experience. And finally, we have the cloud experience, and this is how it looks like. Here, if I take another employee, here employee ID is 2, the name is Taylor. And if you look into the programming skill, this person knows Java, Python, only two elements are there. And on the database proficiency, it is DB2, and again DB2 intermediate level, expert level, and DB2 beginner level. Little bit odd data. This is sample data, so it looks a little odd. And then cloud experience is OpenStack. So if you look into this data set, the programming skill as an array, followed by database entries, followed by cloud experience entries, and they may come in a different order. So order is not guaranteed within this array. Okay, so this is how our employee JSON data looks like. Let's go back to Snow site. Before I run the copy command, let's run a select statement on employee JSON table. I do not have any data set. Let me run the copy command. And since I already have a stage file format type JSON and one employee JSON file is available in this table stage, this copy command will automatically copy the data from this location. And again, if you have not seen my previous chapter, how to load JSON from internal stages, you can refer this particular chapter. So let me run this copy command. So my one employee data is loaded successfully. And first we'll try to understand how the query works with one data. Then we'll go for load a lot more data and see the query performance. Now when I run this select statement, this is the data, and I can see the employee has multiple cloud experience, and the database proficiency is also available here, and the order of the elements are not guaranteed at all. I can copy the data and quickly go back to my editor and revalidate that. So here, after data is being loaded, the order of the elements got changed because JSON does not guarantee order of element. If you look into the programming proficiency, this employee has only one programming language knowledge. The user has SQL Server as well as Oracle database knowledge, and the user has 3 different cloud provider experience. So now let's query the JSON data using a colon notation. This is how my query looks like. So this is my employee JSON table. So this is the column name employee JSON data, and I'm using a colon notation to access all my root element. In this case, it is ID, full name, followed by joining date, date of birth, department, designation, salary, city of birth, and country of birth. Okay, I am also using the double colon notation to typecast the individual element into the appropriate data type, and also giving alias name. Let's run the select statement. So I got all the data, looks perfectly fine. If I have to access the array element like a programming skills or cloud experience or database experience, if I go in a traditional way, I can use the index approach to extract the element. And let me quickly do that. So now programming skills is an array. So I have to, let's start with the first element. Now let's run this select statement. So the language is Java, proficiency is intermediate, and the Java version 7, and year of experience is 9. Looks good. So if I just change to 1, everything is coming null. So this index based element extraction approach will not work, and that's why we have to use the flatten function. So let's quickly write a query which will use the flatten function, and let's see how does it bring the result. So let me copy this query quickly first. The syntax looks like this: lateral, flatten, and then I will take input. Okay, so the input value would be your this programming skill. So I can simply copy this programming skills, and I can say this is my input, and I can say this skill. So I have given this alias name, and here this employee JSON data and this programming skills will return an array, and this array will go as an input to this flatten function, and I'm giving a name called alias. So I can copy this and I can say dot value. Okay, let's run this. Now, if you look into this value has got the entire JSON element, and from there I can use the dot notation or a colon notation. So for example, if I have to extract language, then I can really extract language. So I have to say value. So since value is the name of the column from this flatten function, and that's why I have to use the semicolon before I access the language. Now the language is coming as a Java and proficiency as intermediate. Okay, so this is for one particular JSON file. Let's load another employee JSON file and see how the result comes. So now I am going to load employees underscore 2.json. This is loaded successfully. Let me go back to my Snow site web UI. I can see I have employees 2.json is available. Now let's run the copy command. So employees 2.json got added, and if you do not know why employees 1.json is not added, I would request you to watch the earlier chapter in the JSON playlist. Now I can see two data set. Let's click on the second employee. This is employee 2. Let me copy and go back to JSON visualizer. So if you look into this profile, this person knows Java and Python and having beginner and expert level. So let's run the same query and see what result does it bring. So this time I have two employee records. So I should expect minimum two record, and I have total three programming skills. So I should get more than two result, and let's see how the result comes. For the employee 1, I have only Java as a programming language. However, for employee 2, I have two programming language, and that's why I got two different result. One is Java as beginner level, another is then Python and expert level. Okay, so this is how I can use the flatten function to explode my data and convert my list or a list of objects into individual rows, and then I can really apply another where clause. For example, I would like to apply the where clause to identify all those employees who are having Java as a programming language. Where clause I have two Java entries. When I execute this SQL statement with filter criteria, I should only get this two Java and not the Python. So this is how you can really apply the filter criteria and narrow down your result and fetch a specific data set from your JSON. Now, alongside data timing language, if I have to also use the flatten function, what all database says the user know, for that, I have to add another flatten function called database skill. And I can copy this and I can say database proficiency, I can DB skills. It is a value. So I will change this alias. I will remove the where clause for now, and let's see what result does it bring. So I'm using the flatten function twice to explode the programming skill separately and then database proficiency separately. So if you look, I have got quite a lot of result because it exploded. So this is how you can use a multiple flatten function and explode your data to n number of record. However, most of the cases people prefer to apply the filter criteria that I would like to search all the employees who knows Java at expert level followed by SQL Server as a database. Okay, so to do that, I can really apply a filter criteria again. So when I am querying my JSON, I am telling which all the employees who has Java knowledge at proficiency level expert and also knows MS SQL. Let's see what result does it bring. So I do not have anybody. Let's check what's wrong. So probably I will change it to DB2. This is also not there. So let me change to beginners level. So now I got Taylor is an employee who knows Java as beginner level as well as DB2 as a technology, right? And we do not know what is that proficiency he has it. So this is how now still we are getting a multiple record because every time. Okay, so obviously this is a dummy example. Show you how you can use a flatten and explode function. Let's see how the query profile looks like. So first it scans the table, then it applies the flatten function, and then applies the filter, and after then again it applies the flatten function, then again it applies the filter, and then finally it applies the result. So it is actually applying the filter first followed by the flatten, and that's why sometime you will see the difference in the result. Okay, so keep it in mind. Now let's take another employee data example and try to understand how the path input parameter works. Okay, for that I am going to load third employee, which is slightly different from previous two employees. Let's see how the data looks like. So this is my third employee called Angela, and along with the programming skills Java, C hash, database proficiencies DB2, Oracle, and cloud experience, I also added certification element. And if you look, the certifications element is nothing but another object, and this object has three keys: Snowflake, cloud, and Java. The Snowflake as a key holds a array data type, cloud is also holding array data type, and the third Java is not holding array data type, it is nothing but an object data type. So if you try to construct it, we can use array construct here, array construct here, and for this case I'm going to use object construct. And if you pay attention, since this is another object, it means Snowflake will be treated as a key followed by 0th index, first index, and second index. Cloud will be treated as a key followed by 0th index and first index. Here Java will be treated as a key, and version, pass, and score are another key inside the Java. So if I have to access all the certification for Java, I will say certification 0, second element will be Java, followed by dot notation, version, pass, and score. So now let's go load this data and try to use the flatten function and understand what is the meaning of a path parameter. So my third employee data is loaded. Let's list it. I can see my employee underscore 3 JSON. Let's run the copy command. I created a table freshly, so it loaded all the three data set. So I can see all my data set and the certification is also there. Now my standard flatten function to explode the certification element, I can write a SQL statement like this. So here I am using lateral keyword followed by flatten keyword, and input is nothing but your JSON data dot certification. And so this is your employee JSON data colon certifications, because I want to explode this sub element from the certification element. Now let me run this query. As expected, this is my second record in the entire employee table, and that's why my sequence is coming as 2. If you look into this object, since I'm exploding the certification, everything inside the certification is coming as a this object. Looks good. And there are three keys: cloud, Java, and Snowflake. And these three keys are visible here under the key column. Looks good. And the path to access after certifications is dot cloud or dot Java or dot Snowflake. Okay, and that's what we are going to use in the path. Whenever you have an object which is nothing but a key value pair, you can use the path input parameter. Okay, now let me do that. So you give a comma and say path and this operator sign, and what I want to know, I want to specifically extract only the Snowflake. So I can give Snowflake, and let me show. So this is, I want to extract only this, I don't want any other result. So let me do the Snowflake and let me rerun this statement. Sorry, spelling mistake. So if you make any spelling mistake, uppercase, lowercase, obviously you will not find the result. So I corrected the spelling for my path. Now I can see my key is missing because key is already part of my input parameter. So I am not having any more keys for further exploration. So you cannot apply snowflake dot something because there is no more key available. And my path is snowflake 0, snowflake 1 and snowflake 2, which is nothing but this is my array object. So it will say snowflake 0, snowflake 1 and snowflake 2. So this is what it is showing here, snowflake 0, 1 and 2, and this is the index here. And if you see the value, this is my value, right? If I change from snowflake to cloud, let's see what result does it bring. I'm getting two result, cloud 0 and cloud 1 looks good. And again, this is the result, which is, and this is also matching with my this result. Now let's see when I do Java here, pay attention. The snowflake and cloud are array construct. However, Java is an object construct. Let's see if I use Java, what result does it bring and how the result looks like on the screen. In this case, my key is actually coming here, my version, pass and score. And that's what here, pass score version. And the path is java.pass, java.score, java.version. I do not have any index because Java as a element is encapsulating another object and not an array. And here the actual values are coming. Okay, so now you have understood when you will get value for key and when you will get value for path, because accordingly you can apply any filter criteria to narrow down the result. So let's say I want to really narrow down the score, whoever has passed the Java exam. In that case, I can really write it. So here my key is pass. The key should be pass and value should be yes. Okay. So let's see what does it bring. So it should be path, and then let's run this command. So this is how you can use key, path and index value to apply different kind of filter, and accordingly you can fetch the result. Now let's try to understand another function called recursive, which is by default true. So I'm taking the same employee JSON data, and let me first run this. So this is how the result coming. Now here, if I want to run this explosion recursively, because I already have some key value pair on the line number 2, to do that, I can use another parameter called recursion, comma, recursive. By default, it is false, so I have to make it true, and that's it. And let's see how it changes the result. Now you see there is a difference. So if you look into the line number 1, I have this cloud as a parent object, and it has two elements, 0th element and first element, which is coming here as a value. Then I have another parent element called Java, and that has a value called pass, score and version. And again, it is further recursively extracted and exploded. And then line number 8, I have a snowflake as a key, which is again further exploded with element 0th, 1 and 2. Now you can see the difference. Whenever I am having an array construct, my index values are available. Whenever I have an object construct, my index values are null. However, my key values are present. And whenever you have a path available here without any index value, then only those values can be used as a path. Otherwise, it cannot be used as a path. Okay. So this is how you can use the recursive function. Now, how can I use all the functions? So here I am giving a path based on this result. And since I would like to use this path called Java, so I can say Java and to keep a comma, and let's run this specific path. Now here I can see and not explode it recursively because it just ends there. That's why recursive has no meaning. I can use the mode equals to object, and let's see. So don't get confused just because this is a JSON file. I can just give a JSON, but let's say I change it to the JSON and let's see what happens. It ends with an error. Now let's talk about another parameter called outer parameter, which is one of the important parameter, and you may find use cases where you would prefer to use this parameter to fetch expected result from your flatten query. So for that, I am going to create another table called emp json outer and attaching a stage file format. So my table is created successfully. I'm going to load 4 files into my table stage and then I will run a copy command. So all the 4 record got uploaded. The size is pretty small. Let me run the list SQL command. I have total 4 employee JSON file, and the first 3 JSON file we have already seen. Let me show you the fourth JSON file and how does it look like. This is a fourth employee and the name of the employee is Jessica. And if you pay attention, she does not have any programming skill. So if you have an empty array in your JSON file and when we use the flatten function, let's see how does it behave and how outer parameter is going to solve your problem. So first I'm going to run the copy command and it confirmed that all the 4 files are loaded successfully. Let me quickly run this select statement to see how the JSON file looks like. And I can see total 4 records available here. So this is my flatten query and this doesn't look very different. So I am extracting the employee ID, I'm extracting the employee name, and here is my programming skill, which is nothing but taking an input. Let's run this SQL statement and see which all employee data appears as a result. So if you look into the result, I got the result for Christina, Taylor, and Angela. However, I did not get the result for Jessica because Jessica does not have any programming skills. So to fix this problem, flatten function takes another input called outer, and outer is very similar to left join and outer join in your join world. So the syntax looks like this. So this generally takes true and false. By default, it is a false. When you say outer is true, what does it mean? When I'm going to create this flatten table, even though flatten table does not hold any data for the employee, it will still fetch the result very similar what the left outer join does. So let's run this SQL statement. Now you see Jessica has got an entry, though the language and the proficiency values are null. So when I perform a left join operation between my employee table and the proficiency table, even though Jessica does not have any proficiency, because of that outer flag, it brought the result on your screen. So far, we have managed to process only handful of record. Let me load 1000 JSON dataset and validate the performance when it comes to the flatten function. So I am creating a table called emp underscore JSON underscore 1k with one column called JSON of variant data type. Let's check, do I have any file available in my table stage location? I don't have any record. I am going to load 1000 dataset into this emp underscore JSON underscore 1k. It may take a while. SnowSQL took 95 seconds to load 1000 JSON files. Let's go back to Snow site. So I can see total 1000 JSON files are available. They are non-compressed. Now I am going to execute the copy command, which will load data from internal table stage to the table itself. So 1000 rows loaded. Now let's run this select statement. So if you see, it is taking close to 50 seconds to 60 seconds to fetch just 1000 records, which is not very complex JSON. Finally, I got the result. It took more than expected time to fetch the result, and this is how my result looked like. Now this is a query which is using the colon notation and the dot notation to extract different values. So I am fetching all the data from employee JSON 1k. This is all the root elements from each individual JSON file. Then I am fetching programming skills, 0th element and the first element. And here I'm trying to understand what is the size of the programming skills each employee has. And again, I'm using array size for all the database based proficiency, and I am using array function here to understand the cloud experience. And finally, I'm printing the certification experience. Let's run this query and see what result does it bring. So nothing is specific in this query. I am using colon and dot notation to extract the element from the JSON data. So I got the result, ID, name. This is basically programming count, which I'm using the array size. Now I may see some null values here also. So this is our standard query and standard output. Now we are going to execute the flatten function. And again, this flatten function is using the employee data followed by programming skill, DB competency, and certification detail. For that, I have used three different flatten. The first flatten is actually exploding the programming skill. Second is exploding the cloud experience, and third is exploding certification. And here outer equals to true. It means that only few employees are having certification value, so we just want to make sure that the last flatten is used more like left outer join. So let me execute this statement and let's see. So we have total 1000 rows. However, when we try to use the flatten function, it would explode and number of result would be much more higher than 1k. And we just want to see the performance of this particular query. Finally, I got the result, and let's see how much time it took to fetch the result. It took roughly 68 milliseconds to fetch the result, where execution time was 1 millisecond, compilation time was 67 milliseconds. Let's quickly see the query profile. So when I come to my query profile, I can see that it start with table scan, followed by first flatten, which is happening on my programming skill. Second flatten is on my cloud experience, and third flatten is on my certification. Okay. So, and then finally the result appears on the screen. Scan has read total 8 partition, and the amount of data is relatively very small. So I'm not able to conclude if the JSON performance in Snowflake is very good or not, because we can pass the JSON in a different format. And probably in the next chapter, when we are going to cover how to load JSON using file format and using different compression, including the different parameter, probably we would understand the performance of JSON object in Snowflake. However, my trial and error, I have found the JSON performance is not very good. Uh, what I have observed, if you are trying to keep the JSON as a JSON within Snowflake table using a variant data type, it's not very performant, and it takes quite a long time. I have seen quite a lot of failure, and it takes minutes for showing the result on the web UI. In this long video, we have covered a lot and understood how to use the flatten table function and what is the role of different flatten function input parameters and how they work with object, array, and JSON data type. We also did some mistake on our way and tried to decode the error message thrown by Snowflake during the query execution. If you want to master JSON processing, especially using flatten function, you have to practice them using different use cases and get a clear understanding. Now, you must be curious, what is the role of file format, especially when single JSON file encapsulate multiple JSON objects, and how they can be parsed and loaded, and how the JSON processing can be made faster with different parameters. So my next chapter will primarily focus on file format and many associated parameter with it, and how you can speed up your entire ETL or ELT workload when it comes to JSON. So continue to watch this space and also explore my other playlist, which covers wide variety of topics. Thank you for watching, and if you have enjoyed this video, please give your thumbs up. Keep learning and keep growing.